Hello, listeners. Welcome to the Data Layer by Appen, where we power frontier AI with expert human data. This is episode 1, Benchmarked. I'm your host, Karla Heredia, the Director of GenAI Delivery at Appen. And on today's episode, we're joined by Eric Bezzam from Hugging Face and our own Sergio Bruccoleri, VP of GenAI Operations. Eric, people do know Hugging Face, but may not know your work specifically. What's your role and what are you most focused on right now?
So at Hugging Face, I work on everything that's audio ML. So it can be speech recognition, speech generation, codecs, music. So I'm within this audio team in the open source environment of Hugging Face. And there's two main parts to my job. One of them is adding the latest and best models to this library we have called Transformers, which is super popular on GitHub, over 160,000 stars. It's a very important building block in the ML community. So that's the first part. And the second part is on evaluations, such as the Open ASR Leaderboard, just making the latest and best models accessible and making people aware of them. And both of those fit into this mission that we have for Hugging Face, which is to democratize good machine learning. And yeah, that's what I'm excited about, and that's what we do on the audio team.
Sergio, from Appen's side, what are you seeing from customers around speech AI demand today?
Yeah, so it's very interesting. From the customer side, of course, we're seeing larger demand of more complex audios that is mainly driven by more and more speech models getting into the hands of people, right? And in very complex production grade type of scenarios. So you can imagine lots of overlap, near field, far field, as well as now that sort of generative speech is becoming a little bit more accessible and productized, we're seeing a lot of growth into the multilingual space. And so not only data that is in English, or not only necessarily data that is in English UX accent or British accents, but a diversity of accents, a diversity of markets is definitely in higher demand with our customers.
So I'd like to know from both of you, what made both of your organizations collaborate on this ASR evaluation?
Eric, you
So
go first.
yeah, I can start. So we reached out to Appen, and so we've been maintaining this leaderboard for the last 3 years or so, and it got really popular in industry, but also in academia. And I guess we'll go more into details on leaderboard, but we wanted to reach out. We reached out to Appen to get some high quality data for evaluation purposes and data which isn't at risk for what we call benchmaxing, which is sort of trying to optimize for a benchmark rather than the real performance of speech recognition. Or I'll say ASR probably, and it's a bit shorter to say speech recognition, but yeah, we reached out to Appen to get this high quality data, as Sergio mentioned on accented data, so not just English British, which maybe is saturating evaluations as well. So it was a mix of getting this high quality data, but also this nuanced data.
Yeah, and on our side, on the Appen side is really we see it in two ways. One is we have an internal research team, and we're very, very, very curious to actually look at results and look at really what's going on in the space. I'm sure we'll talk about the effect of private data into the leaderboards later, but really we were curious to see, first of all, how private data impacts sort of the leaderboard, like how big is the phenomenon of benchmarking, but also because we've been doing speech for so long, we have easy access to accents. And that's not necessarily the case for some of the open data sets that are there in the wild. So we really wanted to see as well what kind of role accents play. So there is definitely, I would say, an inner curiosity from our research team to really understand how the reaction of the leaderboard as a whole, right? Where does the word error change? What has an impact on the word error rate? And also, for us, there is, of course, the desire of contributing to the open source community, right? It's so important nowadays. I think Hugging Face has a brilliant mission on just making it accessible to everyone. And some of those people end up being our customers as well. When they pick a model from the leaderboard, fine tune it, and decide what's the best way of productizing a model, we feel like getting that understanding of how models work improve the way we can deliver to our customers. So there is a learning and as well as a curiosity aspect to us.
I mean, this leaderboard is so important. I spent many years improving ASR data quality for big tech companies, and I think a lot of people think ASR is solved. Um, but it's been around for so many years, and I'm curious, why does ASR feel central again in this AI age, and what's changed in the past 2 to 3 years?
Yeah, that's true. That's it's I mean been around for 50, 60 years, and I guess part of it is fueled by science fiction where we just see I mean the interest of it where we see if you take Hal from Space Odyssey or just it's so natural
Oh
to be able
yeah.
to speak to a computer. And we've had iterations where it felt like it's solved, but I think at the same time what's happening is the technology, the way in which we interact with computers is also changing. So we're kind of playing catch up. And I guess what's happened now recently with LLMs is they've been such a natural way to kind of brainstorm, brain dump ideas, but typing is not natural. And then so next the new interface now is okay, how can we speak to these LLMs instead? And that's what's really fueled a lot of the interest, I think, because what ChatGPT dropped 2022 or so, like late 2022, and then people were typing, and now okay, what the most natural interface now would be to speak to it instead. So it's been a lot of interest now, I think, because of that.
Yeah, I think it's. I would agree with Eric. A lot of it is probably driven by the fact that large language models are finally being sort of productized, right? I don't think, I mean, when I look at ChatGPT, when I look at Claude, when I look at Perplexity, absolutely incredible UIs, but are those products that are they really just product for nerds, right? Is my daughter going to interact with ChatGPT, or she's going to be using like a robo-looking tool that is gonna read stories to her and she's gonna interact with in Italian, right, which is our own language. And I feel like because of not language being the natural interface, and then all of a sudden, because it's a natural interface, is not as straightforward as text is. I think it's become central again, and as well probably the progress. Right, we're getting way more low latency now on speech models that allows us to use them on way more use cases. You know, customers. If I think about customer support, right? If I think about a lot of the telephony use cases and 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 similar that benefit from voice AI. I think that's definitely probably the reason why it's central again. It's really becoming a primary interface at this point.
Yeah, and
Yeah,
if
I
I
wanted, yes, Eric, please.
I just wanted to add because there was this whole, let's say, hype around when Alexa came out as well too, like 10 years ago,
Yeah,
because that was one of the first entrants into like a scalable product. But a lot of so my career like in ASR started really with that. But in those products, there's a lot of, you could say, guardrails or kind of things to make
yeah.
sure the interaction is good. But now with these newer systems, they're really trying to let go of those guardrails to have a much more natural interaction. Because there was a lot of with Alexa, we've all had these frustrating experiences where we try one time, two times to repeat the same thing, and it just doesn't work. But they would try to make it work by putting boundaries so that those interactions could be smooth for very, very, very specific tasks.
And I think there are so many ways you can ask for the weather, right, or ask for
Yeah,
sports
exactly.
results. I think just the diversity of phonemes as well that now these speech models have to cover and
Yeah,
sounds that these speech models have to comment is probably unprecedented.
for sure. Yeah.
So, do you think that the release of ChatGPT and all these LLMs changed our expectations of speech systems as consumers?
In a way, yes. I mean, when they first came out with these products, they didn't have these voice features. If I even remember the story of ChatGPT, they didn't even think it would take off like it did. It was just supposed to be a demo for a new model that they had, and then it essentially became their biggest product, the most adopted tech tool in ever, I think, at that moment. Um, and then naturally, I guess if they were trying to find ways, I suppose, to improve the interactions, and then voice came up, and and then there was, I guess, a lot of back and forth in the community. And OpenAI, they actually came out with another model which was super popular called Whisper. That was just about, I think, a year after ChatGPT, and that really um, unlocked a lot of opportunities in voice AI as well, because essentially they had released a model which enabled 100 languages, so people could then fine tune those for specific languages. And essentially they were recycling the same transformers technology. Um, so I guess the if I come back to your question, the technology behind LLMs ended up being the same. That's now the fundamental, let's say, uh, idea or modeling architecture for the neural network is the same for voice now. And that unlocked now a lot of interest in voice again because a lot now can be improved in terms of the quality of speech recognition, but also speech generation. So they kind of went hand in hand a lot. But yeah.
Yeah.
Eric, I'm a little curious, and Sergio, I kind of want to ask you this question too. We're talking a lot about quality, and what's the difference between demo quality ASR and production grade ASR?
Eric, this is for you. Come on.
Yeah, I can jump in.
I'll
I was
I'll
ready. I
I'll,
was ready to answer
I'll
this
add
one
on it.
too. I mean, I so actually before I was working at Hugging Face, okay, I was at a PhD, but then I worked at Sonos as well too, where there we had to deploy speech recognition systems on millions of devices, and I would say there's two main things, maybe even three. One of them is the vocabulary, as Sergio was mentioning, that for Sonos speakers, you're not going to be expecting the same type of vocabulary as like a medical assistant. It's going to be predominantly music artists, and that's a huge vocabulary as well. So that's something we'd have to update, and because you want to be able to say your favorite artist without it understanding something completely else. Otherwise, it'd be completely frustrating. So one of them is the vocabulary for production grade. You need to tune that specific ASR models for the vocabulary of your application. A second, I would say, would be um, let's say the turn taking aspect. So I mentioned Alexa already, where a lot of it is controlled. And in order to make sure that it's not frustrating for the user, you need to be able to handle this in a smooth way and in a way that the user is willing to accept. Because maybe they're willing to accept, and I guess most of us, when we speak to an AI, we're willing to accept, okay, I'm going to take my turn. I'm going to let that AI speak. I'll take my turn. So just making sure that's smooth for the user. And then Sergio mentioned another one, which is latency. The user shouldn't have to wait a minute before the AI responds. So then, and that can come at the trade-off of the quality of the transcription. So those three, I would say the vocabulary, the turn taking, and the latency aspects. That's really what makes the difference between a prototype and something you can put out there.
Yeah, I would add to that probably just one, which is really the environment, right? And it's so hard to get a lot of the okay, how the production environment actually sounds compared to a lab environment on an ideal data set, right? I think there was a time in which speech data sets were recorded with like the best microphones in the world and with no lag whatsoever, with no distortion, right? And I felt like, and even to this day, if I go back to what you were talking about in terms of turn taking and all of that, like a lot of the data sets are still pretty much very single speaker focused, right?
Definitely.
And if I look at up, we're talking about Alexa, let's take a product like Alexa in which you're going to have a TV in the background, or music in the background, or people talking in the background. I think all of those have an impact, and I think it all comes down to as you develop a model, and most importantly, as you develop a product, and in end, really understand where that model is deployed,
For
and
sure.
really understand what are the conditions in which that model is going to function, and is at the end of the day, right?
Yeah, that was something we had to take into account at Sonos. Like, I mean, we had different types of speakers. Let's say a TV soundbar will have a different types of noise than one that's maybe in your kitchen. That's maybe more like a smart speaker shaped. So just as you were saying, Sergio, we would, kind of train these models in those different contexts through simulation. Like in a TV, you would expect, okay, there will be obviously TV noise playing. Maybe the speaker will be against the wall and people speaking to it. Whereas, let's say a smart speaker, which would be in kitchen, would have kitchen type of noise. So really tuning the model to the type of condition, as Sergio was saying.
Well, do you think current benchmarks reflect real world usage with all this background noise and the way that people are actually using speech systems?
So there's some data sets which try to do that, but really to the extent, I mean, it's really difficult. I don't think there could be a benchmark that does that because maybe also different people have different expectations. For example, maybe you would want a speech recognition system in a car or with smart glasses. So, but maybe people aren't interested in that quality or in that transcription. For example, in our Open ASR leaderboard, we wouldn't necessarily put such data sets just yet. Um, so that people don't have this view that, oh, a model is now terrible because of that data set. But if that model isn't expected to work in that data set, we don't want people to have that wrong impression. But we are working on this. Actually, we're working with another collaborator called Treble Technologies. So they want, with them, we're working on this sort of far field robustness type of leaderboard. Because it is a consideration for some people, depending on where they want to deploy it. But I think when we build benchmarks evaluations, we have to be careful of what we include, because people are sometimes just looking at that average word error rate, as Sergio was mentioning, the just that one score. But then if they don't take that time to look into, okay, what's contributing to that score, it could deceive people on certain model performances. So
I think one thing that you guys at Hugging Face have done very well with this release, right? Is that the private track is sort of separate, right?
yeah,
And I
yeah,
feel like I could see a future in which there was perhaps something around signal to noise ratio,
for sure,
right?
yeah.
Across different
So this is
sort of,
coming. This is
hey,
coming on the new
okay,
leaderboard
there you
release.
go.
So
All
stay tuned.
right, so there you go. That's a good one. That's definitely a good one because it's definitely something that we see um, coming more and more and more from the Appen perspective as we work with customers. Is there is an absolute drop when moving into production type of environments.
I want to double click on the collaboration um, for the leaderboard. And I'm curious, why was there a need for a new benchmark? And were existing evaluations missing something important?
So yeah, I mean the first reason why I reached out to Appen was for this benchmaxing concern that I mentioned earlier. On okay, some people had said, who I mean, we get a lot of great feedback, and one of them was how do we know that some of the models that are getting added, they they don't aren't they're not just optimizing for those data sets. Maybe some are. I mean, we don't expect that, but how do we know that some aren't training on those test sets, since they're public test sets that we previously had on the leaderboard before this collaboration? Or people could do stuff which it's kind of gray zone, like they know a specific data set has this type of audio, this type of interactions, and they would say, let me just try to find data like that so I can get better on that data set, which doesn't sound bad, but then maybe that's coming at the expense of general purpose ASR by just optimizing for those. So the first motivation was to collaborate, was to have this private data sets, which only we would have access to, and we could evaluate it on the side, and then report those scores so people can see, okay, we're how does this model now perform on data that it didn't have explicit knowledge about? And then actually this collaboration turned into a lot more. Originally that was the main idea, but then with Appen we realized, okay, they had data on different accents, different types of content, for example, scripted, like a podcast, or conversational like we're having now. So we wanted to be able to break down also performance on those different types of scenarios. So multiple accents, scripted versus conversational. Because that is something that is within the current public data sets, but it's not maybe so clear to users unless they know what is the source of those data sets. But by having explicit scripted, conversational, and different accents, I think this also helps navigators of the leaderboard to know, okay, now how does this model not just perform on data that's unseen, but also on these different types of conditions? And yeah, we're just looking forward to just expand on those different conditions, which we can give the community signal on. Yeah.
So I'm a multilingual speaker and actually have a background in Alexa. So I'm really curious, like, are accents still the hardest problem, or are there newer challenges that you're seeing?
So do you want to go
I
ahead,
think,
Sergio? Or-
yeah, sure. I think, and I don't know how much we can share about that, but I think by looking at the data from the back end, I think definitely accents are still a problem, right? Like in some of the numbers that we were seeing, I think Canadian and Indian, right, were causing trouble to most models, right? It's where we notice actually a large gain or a large loss in terms of accuracy. And so, and we do still see these definitely as one of the main problems. Accents is still something that is extremely hard to nail. Some accents more than others, and I think there is also an aspect of some accents tend to perhaps not only have the problem of the access the accent itself, but also potentially code switching, right? Switching from a language to the other, and so those kind of scenarios become extremely hard for models that are, hey, right now I'm listening to English. What is my confidence that the language has actually switched to something else? But it wasn't necessarily a part of the data that we provided to Hugging Face, but it is something that I keep noticing is like code switching is probably one of the hardest challenges for some of the pairs as well.
Yeah, on the accented data, I mean, we only have one, which is, you could say, a non-native accented English. So it's something we'd want to expand on more because indeed it's something where we saw the biggest gap between, so Sergio mentioned was Canadian, Indian, but if I group, let's say, so the accents we have are American, Australian, Canadian, Indian. I mean, there was a clear gap between Australian, American, and Canadian versus Indian. So, so it's just one data point we have now, but we'd want to expand on that more for other regions to just to be a bit. I mean, I'm assuming there's also when I live in France, so just seeing how some of these systems respond for French accents, you can also see it's not super great there. Um, but yeah, it's something we would like to expand a bit more, give some exposure to that, people some nuance to that as well too. And and yeah, Sergio was also mentioning code switching. That's something we don't at all address because it's very tricky to know how to, because different models will have different ways of addressing code switching. So it's not something we've thought thoroughly about yet, but it's certainly a type of task that we would love to address or um, give some metric on in the leaderboard. But I think
Yeah.
Appen will be great. Appen will be great to work on that with as well too. So
Yes, and I'm a fluent Spanglish speaker. That's Spanish and English
for me,
mashed together. So,
Franglish, yeah.
um, some people think that English ASR is solved. Do you agree with that? Accents aside?
I would say we definitely have a lot of data for US English. So we can build really good systems for that. There's still the task as we mentioned earlier on robustness to different types of noise. Um, yeah, I guess I'm hesitant to say something is solved because maybe we can maybe we can say we have a pipeline for let's say in 3 months we want to deploy let's say an accented American in a car. Um, that's a bit trickier, I think, because getting the car data is difficult. But if you wanted to just do like short microphone American English, I think okay, maybe that we can have a pipeline which is solved, get something out in a few months. But there's so much more than that specific context. It's hard to say if ASR even for American English is solved.
I think it depends on the environment again, right? It depends. I feel like, and to me, is also the purpose of the as someone who manages also indirectly, let's say, a research team. One of the my reading of the leaderboard is it allows people to really take the best model on paper, but then the last mile is always down to the deployment. I really feel like production environment. If someone wants to build something that works on a car, it's probably gonna have to do a few months of collection of data in one car, right? Or is going to have to develop, which is something we do very well, synthetic data that makes it sound like, hey, something is happening in a car environment, right? So definitely, I feel like the problem will never be 100% solved. There'll be models in the leaderboard that are going to get very close to a specific use case potentially, or very good generalist models. And then what the leaderboard really offers is that transparency in that point of view so that you know what you're bringing to the last mile for that fine tuning and optimization.
Mm.
Mm. Okay, this is what I've been wanting to know the most. What surprised you once the leaderboard launched?
With the private data or in the very beginning?
With the private data, but we can even look at the comparison with
Ah,
some of
yeah.
the.
At this point, we want to know everything, Eric.
Yeah.
So, so I wasn't there when it first launched, but still speak with some of the people who started. I think they were surprised just how popular it got because even 3 years ago, people maybe would have thought, okay, ASR is solved. We're just going to make this leaderboard just to have some transparent, some reproducible benchmark. And when I speak with the original authors, they were just surprised at how popular it got and still is. So I guess that's yeah the surprise when it first came out. Um, and with the private data, we were very. I would say I'll speak on my side. I was a bit scared how people would react because private data, open source, Hugging Face, it sounds kind of contradictory, and we wanted to be really sure that we communicate it well. What's the motivation behind this? And so we had many iterations of how do we incorporate the data, and Sergio already mentioned it. How actually what we do at the moment is we don't include it into the default score. It's something that users have to toggle on, say, okay, I want to incorporate this into that average score. And then we also have this separate tab to show, okay, what is the performance? And we eventually came down to this just to help people realize this nuanced view on ASR. And so we first did that because we were scared. But then when we went to ICASP, so this was a conference in Barcelona, beginning of May. So that was the first time where we publicly unveiled and spoke about the leaderboard before putting on online. I was still scared. I was like, okay, let's just get some in-person feedback. But then the feedback was awesome. I mean, we had people at the conference who are building some of those models at the top of the leaderboard, people who use the leaderboard to find different models. And all of them were like, oh, this is what the leaderboard needed, just to have this cleaner signal on performance. And then when we posted online about it, the feedback was also tremendous. So I'm surprised that we didn't get backlash, but I'm happy we didn't at the same time. So that was cool to get that positive reaction.
Yeah, and I mean, I was with you when you launched it, so I
Yeah,
was at ICAS
you
as
were there too
well,
in
since I'm
Barcelona.
in Barcelona. And sort of from the Appen side, of course, one of the concerns was as well, um, okay, are we with this private data, are people going to potentially go, okay, question how it was collected, how it was structured, etc. And I think the way we addressed that, and Eric, you were really good about it, is really looking at the data. I think for months you've looked at the data to make sure you actually had the right diversity, and the right, like it wasn't. Like even if it looks like okay, we found a bunch of data and Appen is fast in providing data, I think Eric and I started talking probably 4 months ago at
Yeah,
this
yeah, we started at
point,
the
and
beginning of the year. Yeah, it wasn't just a data
the
drop and let's just do it as quickly as possible. We wanted to be sure we got
yeah.
this right on both sides.
So the data aspect we've iterated a few times. There was a lot of data that was discarded to really make sure that we had the right diversity, the right, noise levels, the right sort of environments, and definitely still one of the fears was probably okay. They're gonna question a lot how the data was done, but it sounds like that hasn't happened. I haven't received any threats over emails yet, and I think also um, the way the results look and how we address it, or better, how Eric and the team really addressed the separation, I think makes it just another signal for model builders to look at.
Yeah, and I think the nuanced view also helped people because I had some people when they just saw the average of the private, they're like, "Oh wait, this seems weird." But then I showed them the scripted conversational split, and they're like, "Ah, okay, yeah, that makes sense," because they could see the scripted is much, much lower than conversational. Or when they saw the split on accents, that helped a lot. So,
Yeah.
yeah, we wanted to be sure we yeah, that when I mean me on the Hugging Face side, Appen side, we were the only ones who could access data, and we wanted to make sure, okay, comparing that data with others, we wanted to make sure it reflects what people are expecting, but also that it could be of higher quality because it's known that in these public sets there are some transcription errors or other stuff, and we wanted to make sure we wanted to limit any of that was in the private set, so it's a very clean signal, not just on this any test set contamination issues, but also in the audio and the transcripts themselves.
So, did you handle this evaluation data different to maybe the way that you would evaluate training data? Are there differences in those? And Sergio, I think this is a little more for you. How important is evaluation data compared to training data?
I think there was definitely an aspect from our side on making sure that there was no subjectivity within the data, right? Especially, certain words can be transcribed in different ways, right? And you want to make sure that your golden set is sort of objective, right? You cannot have something that is confusing or that can have multiple hypotheses, right? So we really focus in terms of building the data, making sure that the data was more absolute in the way it is done. And I think also there was a lot of back and forth between Eric and I on how the word error rate and how the normalization of that data set would actually happen before those word error rates were computed. And there were a lot of ideas on how to really make sure that normalization is fair to all the models that are in the leaderboard, right? Because sometimes models transcribe things in different way. So how is that addressed, and how sort of make sure that models aren't penalized for things they shouldn't be penalized for.
Yeah, that's especially important as what Sergio was saying. You don't want to penalize a model if it's doing something correct. Because I'd say on the model building side, that would give them a wrong signal of if they see an improvement, maybe it wasn't actually a real improvement. Maybe they were just overfitting the test sets that had those errors. And then on the benchmarking side, we don't want to, yeah, it's a lot of maybe people will come on our side to see it more as a relative comparison. And we don't want, yeah, to penalize the good models because they're getting something correct. And then on the normalization, just to give some concrete examples of what Sergio was talking about. So one of them could be how you spell certain names. For example, Catherine could be with a K or a C. So actually with this data set, we were able to improve our normalizer to realize, okay, we need to handle some of these name mappings better because there's going to be multiple spellings for the same pronunciation. How we handle things like acronyms. So what we were already handling correctly was punctuation casing. That's how the normalizer works on the leaderboard. So what we do is we strip off all of that because not all models and not all data sets have punctuation casing. But yeah, this data set helped us think deeper onto the normalization aspects, and yeah, some improvements we want to do in the future, just as Sergio was saying, not to penalize wrong model or good models. But yeah, so it's
And I
especially
think
important. Yeah,
one of the things that you guys also sort of do very well is that the evaluation scripts, right? They're all pretty much open source and available. And I think really that helps
except for the
build
private data
trust.
ones. But yeah, but yeah, we make
Yeah,
it public.
yeah, and I think
It's the same logic.
I think one of the things though is really, there is obvious reasons why we cannot make the private data and it's benchmaxing, right, available. But like in terms of openness, I feel like the Open ASR leaderboard, apart from that, is probably one of the most open leaderboards that exist out there in terms of transparency. So I think that really also helped people with the reception, right? Because
Yeah,
I don't know if there are a lot of organizations that can pull a private data set and just not get negative reaction from it. And I feel that, and I think I didn't phase as a plus because of the fact that you guys have always been very open with the space. Okay, this is how we're doing things, and it's all really, really, really with the purpose of driving progress forward, right?
for sure. Yeah.
Speaking of pushing forward in the future, do you think that synthetic data is ever going to replace human collected speech data for uh, the leaderboard?
I don't know if for the leaderboard, Eric, but I would love to hear I think as a developer, or as someone who has developed, let's say, I would be very uncomfortable with synthetic data on the leaderboard.
Yeah, I
Maybe
think.
synthetically augmented,. I have no problem with. So
Yeah, yeah.
data that is original, like the speech is original, but maybe the environment is synthetic. I'd be fine with that.
Same. I mean, I think for training, maybe you can make a case for using it for evaluation. I mean, on you don't need, let's say, that much data for a good eval set. The really important is that you have a small amount of high quality data, and it's worth the effort of getting actual measured real human voices rather than synthetic data. So yeah, I don't see any reason why we would include synthetic data in the leaderboard, except for like augmented real speech, like Sergio was saying, maybe to simulate a car setting, to simulate a kitchen setting, but always being clear to the user or to the person who comes to the board that those noises or augmentations are simulated. And I think that should always be complemented with a real measured type of situation so people can see it's this notion we have in the field called sim to real gap. Like, maybe you get this performance on the simulated context, but then the natural question people should have is, but how does that generalize to a real noisy environment? And I think using synthetic speech would be a bit too large of a sim to real gap, so I wouldn't include
Yeah.
it in a leaderboard.
I want to talk about the private track and why introduce it now?
So, so yeah, as we were mentioning before, this concern of test set contamination was quite real, and we heard it not just from people developing models, but also people coming to the leaderboard, and we felt it was an important time now to address it, and also, yeah, just to give a real signal from the leaderboard. We hadn't updated the data sets in quite some time, um, so yeah, it was a good time to introduce it for this.
Do you think it's going to be updated more now that you guys are getting into the rhythm of updating it?
For sure, yeah. Yeah, even also including more private data because um, even yeah, it's even though it's more difficult to benchmax, speech is sort of a moving target. Like we have different applications. Maybe, for example, smart glasses I hear are getting super popular. Maybe we would want to include a data set with this at one point, or adding more accents as I mentioned, adding multilingual on the private side as well too. Um, so it's an evolving. I mean, language is also evolving. So there's yeah, keeping up to date the data sets is important for us, and the private was kind of serving two purposes in that. But also, I guess you can also people can also expect on the public side, we're also going to be doing some updates on the data sets too, because what we want to make sure is that if we have a private, we have hopefully a corresponding public one for this. So.
So do you think the industry is going to eventually move towards more trusted private evaluation frameworks?
I think industry will always have their own internal benchmarks, and probably one of the reasons why the Open ASR Leaderboard got so popular was because it's a good communications tool. Like people can say, "Oh, we got this position on the leaderboard," and I think that we introduced the private set gives them more confidence now in such communications to say, okay, because when we released, it was funny when we released the private track, we could see I saw different companies spinning in different ways of how oh we're doing better on the private track now. Oh, if we include everything together, so it gives companies maybe more ways to communicate their models. Because on one hand, it's nice for a company to say we're doing good on public sets because you can check it yourself. But on the private, they can say, oh, but these are really high quality because they trusted the process that we had. Or if you combine the two. So we like that people have now this nuanced view of ASR. It's not just about one column or one number, but okay, there's multiple numbers. And I think having that split helps people understand the nuance and also, yeah, just distinguish hopefully between different types of models and different applications. So.
All right, this is my last question. I'd like to know from both of your perspectives what you think speech AI will look like in 5 years.
Eric, you go first. You
I
need
go
to think
first?
about
Okay.
this one.
So I guess, two aspects come to mind. We mentioned one of them was the turn taking thing, and so there's this term in the field called or terms half duplex, full duplex. So half duplex is really the types of system we have now, where the voice AI system is either in listening mode or speaking mode, and most are built out of that because it's easier to separately build the recognition and the generation system. But I mean, recently people are now having a lot of interest in what's called this full duplex, where as humans, we can interrupt, but we can also be interrupted. So I think the future systems are, from what I see, like for example, when we're at this ICASP conference in early May, yeah, people are moving towards this because it's much more natural as an interaction. But the difficulties are training it and evaluating it. We're also missing a lot of data for this. But I think, yeah, within the next 5 years, there's going to be a big push for this type of full duplex, more natural interacting systems. And I guess the other big change I would see is just how these systems get deployed. On one hand, like the systems we've typically seen them so far are like smart speakers in cars. We've had them for some time. So these are very static systems, but now we're having these systems in more dynamic situations, like smart glasses where users moving, or even now in robotics where there's going to be a humanoid or some sort of moving robots that's also going to have to take into account speech commands. So that's going to bring in new challenges. And I think in the robotics phase, they're still quite early in just making the robotic work mechanically. But I think we'll see a lot more interest in improving the voice interface in robotics as well too. Similar as we saw for static Alexa type devices, but with moving, it's going to bring new challenges. So yeah, to sum up that, so the robotics and new contexts for ASR, but also this more natural turn taking. That's what I see people pushing towards the next couple of years.
One thing that we're seeing a lot on the Appen side is also uh, probably the value of directional signals within audios, right? If I think about robotics as well, but if I think about some of the use cases that we're seeing, okay, is someone shouting because he's from afar, right? How does that change the interaction and how the large language model aspect of the model responds to those signals as well as emotions that are carried through voice? One aspect that I would like us to solve in the next 5 years as well is probably more accessibility of speech models in general. I think, you know, there was a lot of effort done prior when we were still guardrailing models in making sure that they work for people with speech impairments, for example. And I think that is a problem that models don't necessarily account for as much any longer. And I think making these not only a solution that makes LLM interfaces accessible to people, but to everyone would really be something that I'm looking forward to.
Sergio, Eric, thank you so much for today. This chat was great, and I look forward to speaking to you guys a little more.
Thanks, Karla.
Thank you.